let's get started, right? So let's talk about Harbor and containers. And you cannot start a slide today without mentioning AI. So here is my mentioning of AI. I will mention it another time, but very briefly. So my name is Vadim Bauer. I'm a software engineer by heart. I'm not developing that much anymore, but I'm still call myself a software engineer, developer. I'm in the industry for like 20 years or more already. This is my first computer. Actually, not exactly the one, but it looked exactly the same like everyone else's. I live currently in Zurich, and so it was a nice travel coming here. And you can find me on those social media channels. You just look for me. And you know, I'm the maintainer of the open source project, CNCF project Harbor, since 2020. I've been running container in production since 2013. So that was actually in Christmas 2013. We've been the first one, not the first one, but among the first one who deployed software to production with Harbor, with Docker. Nothing worked properly there at that time, but the application did work, right? But everything else didn't work. I run also a business. It's called 8Gears, and we have a 8Gears container registry, and you can subscribe and use it. It's a Harbor-based offering, and it's also present on Exascale. So if you're on Exascale Marketplace, you can look it up, and you can also use it. It's running also on Exascale. And I like to go snowboarding in the winter, so I'm looking forward in the next 2 weeks to get started. Yeah. So today I would like to talk about Harbor from a few different perspectives, right? I'm not going to talk about Harbor in all details because it's a bit dull. I'm going to talk about like more the workflows, like the developer works. What's the benefit what are typical developer workflows that Harbor can cover, and or that you can also do with other tools, but where Harbor helps, like tag immutability, versioning, release gates, labeling, and why it makes sense. And also for the CISOs and for the ops people as well. So let's get started with a quick overview about Harbor. Harbor is a container registry at its heart, so it does everything what every other container registry does as well. But it adds a few functionalities on the top, which is like policy, role-based access management, vulnerability scanning and signing. So it's more of not a registry for storing images, it's more of a thing to manage container images, right? So this is how it looks like. It has even a UI and a REST API and like this. So you have like you can have projects, multiple projects. You have configuration. So nothing really special about that. So this is a feature dump. So I'm not gonna into detail all about the features, but if you just briefly look what is there. So it turns all around about managing things like role-based access control, isolation, artifact distribution, compliance, and things like this. So there are some enterprise features. What makes it really interesting is if you look at it from the perspective of the users who are using it, right? So I call them a bit of like a superpower for different type of users. And surprisingly, this Harbor works very well for small teams and large enterprises, right? Depending on the features you add to it, or not adding, but enable it. So depending on how many features you enable, like you enable OIDC, you get some more options like groups and things like this. You can import a lot of things there. So it grows with the type of functionality that you need. So it's we see people with like 5-6 developers using it and super happy with that. So it does not add too much complexity if you don't need it. It has a few functionalities that support developers, right? Like developing software, deploying software, and I'm gonna walk over that. It makes also a few things that makes CISOs happy, which is like having all the images in one place, so you can do things like image replication to have everything in one place. You have vulnerability hub, you can see like the vulnerabilities in your images and things like this. But it also makes ops people happy, and I'm going to also look into that, how it makes ops people happy. I'm very happy because I'm not using that much GIF as you, but I have also a few that developers, right? So developers are important part, and it's I'm happy to see that it's also supported in Harbor, because, well, they're the ones who are doing things, right? And it's important because I was last week at the KubeCon, and there have been like 5 topics that I found been discussed all over the place. So first thing was AI, right? So it's basically really like the time now to sell shovels to AI, right? So it's like really a gold rush there. And so of course Kubernetes and CF are on the train again. I asked DALL-E to create me an image, and this is how what is generated. So this is the second mention of AI today. Then platform engineering is also a very important topic, and the third topic that was very important or also mentioned a lot is developer experience, right? So how can this whole CNCF ecosystem help developers do their work best? And they call it end user experience, because from the CNCF or Kubernetes perspective, like the end users are the developers, so they call it end, yeah. But it's about developer experience, then sustainability and WASM, right? So this is important topic, developers, and we're going to focus today on that a bit and the workflows. But just give you a brief overview about the architecture of Harbor. So it's a multi-component application, so it consists of multiple components like a database, a SQL database, Postgres, Redis for caching, and some other things. It is based on Docker distribution, so we have underneath Docker distributions, and we add a layer on top which has all these management capabilities. And it has also like the job services like cron jobs, like synchronizing jobs, like garbage collection jobs, which is not running in Docker distributions. It's separate things, and has like all other components. But so it's fairly complex system if you consider everything together. And comparing to other registries, right? So I mean, basically it's just storing images, right? So this is like that every registry does. It's storing images. But what it's a bit different is like how you for what type of use cases, right? So if you take a look like things like ECR, Google Artifact, Azure Container Registry, they're more project focused, so that they give a registry to a developer, and developer can push to this. And Harbor has a more of a kind of a holistic image management approach to all the images in your organization. So this is like a major difference between what you see in the cloud providers offering and what is, how Harbor is used normally. And then the artifact management tools like Artifactory, Sonatype, they are of course more capable than Harbor, because Harbor just stores container images, and those tools are storing NPMs, Maven artifacts, and all other artifacts as well, and have a lot of enterprise capabilities. However, they, on the other hand, because they have support so many artifact types, they make compromises on the container-specific capabilities, right? So that's understandable too, right? So this is like kind of a rough overview, and so let's look at the replication. This is not the right title, I think, but you can play around with Harbor. So there is a demo instance which is reset every week, and you can access it. It's called demo.goharbor.io, and there is admin credentials. That's admin@harbor12345. It's very secure, but you can log in, you can go there, you can do everything that Harbor has to offer, right? And you can try out all the things that you want, which is really powerful because it's the latest version. It just runs, and you can try it out without needing to register or something. Yeah. So let's focus a bit on the typical developer workflows that we have as developers, and see how a registry can support us in that regard, or more specifically Harbor. Like the first thing is like tagging and versioning, right? So tagging and versioning is an obvious thing in software development. We version our artifacts, and there is however a bit of a difference between container artifacts and typical software artifacts, right? So in a typical software, artifacts are immutable, so you create an artifact and it has a version attached to it, and that's it, right? In the container world, we have a container image which is immutable too. However, the tag that is attached to the image is mutable, so we can attach this, or we can move or reattach this tag to another container image, right? And this is on one hand very convenient and is really used a lot. On the other hand, it has of course some problems, because you can attach the version 1.0.0 to any other image, and this can cause a problem in production. And so what options do we have when we version an artifact, right? So we have different types of options how we can version an artifact, right? So there's like the simplest way is just use the digest, because each image has a the hash, and so it's ID, it's digest. We can just use this one, but it's really hard to manage, and it's hard to use if you just use this digest, right? We have the rolling tags, we have the semantic versioning, we have the git commit that we can use as a versioning, right? So we have kind of more options than, let's say, in the classical artifact versioning system, where we mostly use semantic versioning, right? So we have multiple options that are commonly used in the containers, and it's even combined together. So you can use, for example, git commit with a timestamp, right? Or you can use a rolling tag with a timestamp, or git commit and things like this. Yeah. So when we look at how the container images are tagged normally, right? So this is Docker Hub. You see that in Docker Hub, like each image has multiple tags attached to it, and depending on where we stand, we are rolling the tags. For example, this the tag here, bullseye, right, on 3.12.0 is rolled over when the new version is available, right? And then so we reuse tags, and then depending where we want to be, we want to be able to follow that. For example, 3.12. We just set on 3.12. We just follow. We want to follow version 3. We set it here, or we just want to follow the Linux distribution. We just set it here, right? And then we'll be automatically updated. So we have a kind of a rolling system in Docker, and this is mostly all official images are applied to that. Super nice functionality. Problem is if you want to have it fixed, right? So if you want to have it fixed to a specific version, or you want to make sure that you only have this version, right? And so this is like how we can reuse how the images are reused. Yes, and what we need is a tag immutability, right? So we need to make sure that the tag that we once attached to an image is never changed. And this is, of course, not part of the specification, not a part how Docker or container images are designed. But it's a feature that sits on top, and you can have this, right? So this is like a functionality that you can enable if you really want to make sure that your tags are not rolled. And this is done with immutability rules, so you can really specify the immutability rules on specific versions. You don't want to apply your immutability rule on latest, right? Because if you apply it to latest, then you just can't push latest one time, right? And so you can specify it specifically to semantic versioning, for example. Currently in this snapshot and this version, it's just you have just a star and star notation, right? But in the future version, there's going to be some regular expression, so you can set that it only one that has like three dots should be immutable, and other not. Then labels. Labels on artifact is something that is not very commonly used. So why do you want to have labels on artifacts? So what is the benefit of having labels on artifacts? And labels on artifact allows you to provide your artifact with additional context. So it's kind of a metadata that you attach to your artifact, and you can use it to control your pipelines, or to give some outputs of pipelines, attach it to the artifact, right? So you can, of course, wrap it inside and things like this, but it's helpful to just attach some sort of a label. In the workflow stages, you can attach test results as a label, or you can even attach kind of environments as labels, or kind of release gates. And this is something that you can also use in hardware. So you can attach this type of labels to your artifacts or to your OCI images, right? And this can happen on the project level. So each project can have individual labels, and then the whole organization, the whole instance can have labels too. And this additional level of context allows you to create different types of workflows, right? And you can set labels in your OCI pipeline to say, for example, that this pipeline and this artifact passed test, right? And then you can use this pass test to deploy to your test environment, and then you can label it then, okay, deploy to test, and then you can label it deploy to stage, and then you can say only images that are past test, deployed to stage should be able to deploy, right? And we control that one. And then the other thing is, like, you can use also label-based replication. So I'm going to explain a bit what label-based replication means. So when you deploy, it depends of course on the environment, but in larger organizations you mostly have more than one registry, right? So you have a registry, maybe a central registry, and then you have a registry close to your cloud provider. So you might have one on Exascale, one on AWS, one on Azure, because it's easier to push it to this registry and then pull it from there multiple times, because it's cheaper, right? So, and also it's faster. And then you have also a lot of times you have the cloud providers registry have built-in tools so that you can automatically pull from your pod or your cluster can automatically pull from the registry, because the secrets are automatically injected, or you can configure it to automatically inject secrets. So it's very convenient to use the registry of the cloud provider, and you can use those release gates to help you with that, right? And the replication in combination with release gates to help that. So you can create those labels, and then the labels can, based on the label name, can be replicated to another registry. So you can say, like, every few minutes or instantly, whenever a label is set, and if this label has this name, it should be replicated to another registry. And this replication can happen, of course, to another registry, but can also happen to yourself, right? So to your own registry, but to a different project, so that you have like a separation, like a prod project, a dev project, and a stage project. So you can replicate to yourself, and because you're replicating to yourself, it doesn't consume any more additional storage, because it's just references. And so you can create kind of release gates or share images with other teams if you have really a kind of separation between teams. Another topic, which is OCI, I call it OCI all the things, because OCI is the Open Container Initiative, and OCI specification is specifying how to store container images. And when we look at artifacts and see, okay, what is an artifact, right? An artifact, the official specification or documentation of an artifact is called, it's a byproduct. It's a byproduct of that happens during software development, right? And this can be, of course, like documentations of all sorts, like your user manual, your requirements engineering documentation. So whatever documentation you have is considered to be an artifact. The same as the code base is also considered to be an artifact. Like your test cases, your test data, even your test plans, all those things considered artifact. And the executable software, in this case container images, is the artifact that we are mostly talking about. But it can also be configuration, and this is something that you can think, okay, I can save my configuration in a registry, and I can use it during deployment or during deployment configuration. Would it be not interesting to kind of combine the software artifact or the image with some different types of configuration? Well, you can. And you can do it yourself, or you can use, for example, a tool which is called ORAS. ORAS stands for OCI Registry as a Storage. So it's really an abbreviation to say that you can store everything in an OCI compliant registry, and there's a tool, it's called ORAS. It's the CLI and SDK, so you can even embed ORAS into your project and stores things in a registry. And Helm, for example, does import the ORAS CLI to store Helm charts in OCI registry. So this is how they're done, and this is quite simple, right? So you have an CLI. You can create you push to a registry. You specify an artifact type, right? So you need to specify an artifact type. In this case, we specify the artifact type, which is called artifact text plain, right? So it is own type that we created, and then we select the file that we want to upload, and it's going to be uploaded to our registry. Simple as that. And this opens up a new possibility so that you can also kind of separate your application and your configuration, and you don't have to check in all in one registry. You can have multiple artifacts stored in the registry, specifically configuration, like even if it's when it's a bit more complicated, you can do that. And with the specification 1.1, which is released recently, you can create references in OCI images or OCI artifacts. So this means like your OCI artifact is referencing another OCI artifact. So this is mostly used for attaching SBOMs or attaching attestation, like the signatures to images. This is happening with the reference. So you basically create a layer and is attached afterwards. So after you built your image and the image is already present on the registry, you can go there and attach or reference another type of artifact to it. And you can use the same things for your configuration, right? And then you can deploy to different environments, or you can attach whatever there is to be attached to your software artifact, or reference to a software artifact that is dependent on the release. Yeah. The same, like the next thing is like when you work, mostly work in collaboration, so you need a way to distribute your software. Mostly it's with your customers, with your clients, or if you're working with someone together. So you need a way how you can collaborate with partners that and where you can share your software or containerized software, right? And so you can collaborate on containerized software with clients. You can replicate images to your clients. If you're building software in an agency, for example, you can just push things to your customer. You can collaborate with your clients, so you can onboard them onto your registry, for example. And this is a bit easier than with registries that don't have a flexible IDP system, right? It's like Docker Hub or ECR, ACR, so where you have to do IAM things to onboard external users. And so you can even go and sell container images. We have a few users who do this, and you can use even your registry key as a license server, right? As a pseudo license server. It's not fully license server, but you can use it to check if the token is alive or token is valid, and then based on the validity of the token, you can decide if your software should run or not, right? So you can do kind of a poor man's approach on a license server. And this is, for example, how Elasticsearch does it. They have their own registry and their own marketplace kind of things where you can buy or see which images they currently have, right? And you can also kind of create something around, I call it container vending machine, right? So where you can build a system that customer can directly buy images, and then they get the pool token sent to them via email, and they can access the images that you currently sold to them. Right. So let's talk about how we can make CISOs happy, right? So what are the most, or not most, what are the critical aspects of container security for a CISO, right? So if we take the role of a CISO, what does he have to look for, right? So he needs to know what are the vulnerabilities in the software artifacts, what are the vulnerabilities in the images, right? So those requirements are very important for them. They want to be that they have a compliance and policy enforcement desire, right? They want to be that some the software artifact and images are compliant to certain policies, and they of course want to enforce those policies, right? And enforcing those policies happens normally during runtime, so this is not happening, or before runtime, this is not normally happening at storage time, because it's a bit difficult to enforce it there because they're not running, right? And then the access control to artifacts, like who should be able to access artifacts, who should not access artifacts, and then integrity, like the typical use case that we see in the supply chain security today. They demand like signing and verification process of ensuring that the images that you have are from the sources that you think they are from, right? And that they are signed and verified. And the problem here is is that the supply chain is big, right? So supply chain is big and complex. It's just not about container images. So if we take a look at the supply chain, we see that we have a lot of places where those supply chain attacks can happen, or where problems can occur, like from the producer to the source code, in the source code, from the source to the build, then in the pipelines, then in the dependencies that we get. So there's a lot of things that are not only on the packaging side, right? So the packaging side is just one piece of the whole puzzle. And so what we can offer is in Harbor, because we are dealing with artifacts in rest and not at runtime, we can provide a vulnerability overview, like what is the current vulnerability status of your images inside your organization, and then you can see what is the top vulnerabilities. You can export the data and you can process it. This is kind of one of the capabilities that exist. And when we talk about signing images, of course we can sign with cosign, with Notary 2. The thing is that verifying images at rest is a bit difficult, or it makes little sense. Mostly you want to do it at runtime, right? And there are quite good tools that can help you verify signatures at runtime. This makes less sense on the storage side. So when you store an image, there is an option that you can kind of deployment security, where you can say that you don't want images to be pulled if they're not signed, right? So this is like one gate of many that you can implement, but the most critical and important one should be at runtime, right? So like, for example, with what's called this tool, Kyverno or policy agent, you can then enforce that your images, or verify that images have signatures and the correct signatures as well, right? Happy ops people. What makes ops people happy, or DevOps people, depending on how you see it? So there is a kind of a demand on desire from ops people, right? The first demand of ops people, they want stability. Nothing should change. Never change a running system, right? So the first desire of ops people is, of course, stability. Nothing should change. Then the maintainability. Things should be maintainable, right? Maintainable in a reasonable amount of time. And the other thing is a bit of paradox, because on one hand, ops people want to have control, so they want to have control about everything. But then on the other hand, because they don't want to do everything themselves, or everything themselves for the developers, this is like where DevOps come in, right? So you need to delegate control to developers. You need to have a way how you can delegate control to developers, and this is where, and the other things like how to do automation and scripting, and also like GitOps workflows today. And the typical use case that we see, or the people apply with Harbor, is the infrastructure as code, right? So you can do some point and click on the UI if you want to. So if a small organization, this is totally feasible and usable, but in a large organization, you want to apply maybe GitOps workflow, and this is something where you can, for example, use Terraform or Pulumi, and then you can create a GitOps workflow where developers can request, for example, projects, or developers can request replication rules, or they can request other things like global labels. So you can control a lot of things, or you can delegate a lot of functionality to developers if they create pull requests. And you can do this with Terraform, or you can do this with Pulumi. Then this is a typical workflows. Outlook. So this is like what I'm currently working on the Harbor side. There is now a big trend in running Kubernetes on Edge, and if you want to run Kubernetes on Edge, you need some sort of an image registry at Edge, and you need to have it close to the Kubernetes cluster, and not too close, but you should not never run your registry on the same cluster that you have the workloads. So you want to have it close, but not too close, and this is where kind of an Edge registry comes into play. And this is where I'm currently working on how Harbor-like registry working for the edge use case. Then SBOM is an important topic as well. It's part of the supply chain. So that's like how to get an SBOM visualized in Harbor, how to get it there and attach it to the artifacts. And also export it, of course, because you don't want to just store things in Harbor itself. So you want to store it, but also make it accessible. So in the downstream, you can process the things. And then, of course, the other things that we are currently working in the community is opening up the registry, because there's, with auras and other things, there's a big trend, so that you can support OCI for other types of artifacts, right? And we're currently looking at how can OCI support NPM and Maven artifacts even, right? Thank you very much for your attention. I think if we have, we have like 2-3 minutes for questions, right?
Yeah, exactly.
So if you